Hello, hope you're doing great. This is Mariappanni Rajan, your friendly software engineer. And in this video, we're going to talk about loops in C++. Now, before we actually talk about loops, we need to, let's just think about certain things, all right? So, as human beings, we are really good at being creative, right? So that's our forte, right? We crave novelty, and we are always thinking of better ways of doing certain tasks, and like new ways, rather, like new and better ways of doing the same things, like the same, let's say for example, the way we we have this written communication, right? Like before, when a lot of years back, during the caveman age, people used to maybe write on write using stones on the rocks, right? So that's how they wrote things and communicated with each other, the written communication. That's how it was. And then we figured out that we could maybe use like some wood to or maybe some charcoal, like that was a better way to mark things on the wall. And maybe then we figured out that we could make some wood and create some kind of a pencil and use that. And then we figured out that maybe we can create an ink, like some kind of a paint that could be used. We even were using this bird's that quill, right, that feather kind of a thing for writing. That was another way we did the same thing. It was the same task. It was like the task of writing something, right? So that was the objective. But as human beings, over the years, we can see that the same thing, we are doing it in new and creative ways. And like after that, the bird feathers, like we figured out that we can put some ink on like a small tube, which we call it as pen. And we know that we have all these different types of pens. And then like when the computers came about, today it's all digital, right? We're just typing, our written communication is all done using using our typing skills now. And then now, as the next step, we are now able to just orally say what we want to get written, right? So as humans, we are always thinking of new ways of doing things. That's our natural state of mind. Like we have our brain, our creativity, and we can actually keep coming up with better and creative ways of doing things. But at the same time, we hate doing the same thing over and over again. Like asking somebody to just do a mindless job over and over again, that's like torture for any human being, right? So as a matter of fact, like I just have this hand fan with me. All right, so this when there's no power, we usually use it, right? So this hand fan that I have in my hand, like for it to give me air, I need to do this, right? I need to wave my hand up and down using this fan, and that produces some air. So this is cool. And as a matter of fact, if you see these olden movies and all, and the black and white movies, I can see, especially the King movies and all those things, there two people will be standing, one on the right side and one guy on the left side of the king, and would be waving like this huge like hand fan, and to produce some air to give some like nice fresh air for the king. That job would have been a horrible job, right, for that those two human beings, because all they had to do was the entire day just stand idly without thinking, without being a human. They just had to keep on waving like some air for the for the king. So even today, we seem to have all these like mundane work that are given to people, and they just are expected to do just this mundane same thing over and over again. And that's horrible, right? So that's that's a very bad place to be if you're just asked to be a fan. When we clearly know that today we have today thankfully we don't have people who are just standing next to like kings, or like big people who are, and just waving hand fans at them. We have, because of the machine that we have, right, that the fan, electric fan that we have, like if you just switch it on, it just keeps on spinning over and over and over. It just keeps on looping, right, over. As a matter of fact, I have this like electric hand fan, right? So see, if I just turn it on, like it's just spinning, and it just keep on spinning until I switch it off, or if it runs out of power. Like that's the only condition where it will stop. Until then, it just keeps on spinning and producing like nice air for me, right? So this is a machine that is doing it, and the machine doesn't mind doing the same thing again and again. As a matter of fact, that's the strength of a machine. A machine, can just be a machine will just be in a particular state of motion until you change that state, until change its environment. It'll just keep on doing the same thing again and again, given a particular given some electricity, given some electricity, and given the proper circuit wiring. It just keep on functioning, it'll just keep on spinning. You don't need to manually. It doesn't expect a human being to come and wave it, right? Like a human brain is not required. A human brain is not a human brain doesn't need to be wasted for producing air to people, because we have these machines that are doing these loops. The machines are iterating, they are just keep on, they're just rotating, and over and over again, just doing this mindless repetitive work, and still adding value. There is value, there's definitely value in repetitive work. There's definitely value in repetitive work. It's just that machines are much more better at doing these repetitive tasks than human beings. And more than the repetitive works, it's more important to be creative for human beings, right? So so that's the that's one of the main reasons that software is so powerful, because it has this ability to automate repetitive tasks, right? Like say, for example, if you want to do calculations on some thousand numbers, right? Like you just need to set the formula for one particular you just need to create the formula and put it inside of a loop, right? And if you just give the data set of those thousand numbers, that calculation gets performed on all the thousand numbers. So that can be done. These kind of repetitive work on large data sets are possible by means of these loops that we have. All right. So till now we have been discussing about how we can make use of variables, right? So variables enable us to store data, right? So we have all these variables basically help us to store different data types, such as int or float or characters. And then we have these data structures, more sophisticated arrangements, where we arrange data in a more sophisticated manner, where data structures such as a list, and then we have we can create data structures such as a list, where you arrange all these data in a sequential block, so that you can just iterate. You can just have all that collection. You can access the entire collection, entire list, in using just a single variable. And there are many other data structures that are available. We can create our own. We can create our own as well, right? So like a queue or a stack or a dictionary, and so on. So there are all these different types of data structures that we can create. So we discussed about them. We especially discussed a lot about list. And yes, so a variable and data structures such as list and whatnot are used for storage, right? And also we discussed about the decision trees that we can create by means of using the if else statement and the switching statements, right? So that so basically, like, the data structures enable us to create basically store and retrieve data. So we have the data structures which include all the variables, all the list and tuples and whatnot, so all the different types of data structures. So we have the data structures which enable us to store and retrieve data. And then we also talked about in the last couple of sessions about the logical statements, which are basically the if else and the switch statements, which enable us to add logic to our system. Like we can create we can make the system intelligent, basically make it give it the ability to make decisions, right, based on the data that it receives. So you have data structures and you have logical statements. You can add logic to your system by means of having if else statements and switch statements. And then the next most important part, right, like after data structures and logic, is loops, because the data structure enables you to store a lot of data, right, and logics enable us to create logic on this lot of data. Now to iterate on all this huge amount of data that we want to process, we need a system, to iterate on this large data. That is what loop is, right? Loops enable us to iterate and loop over huge data sets. They just, you can just keep on. There are even infinite loops that you run, especially, like if you are building a game, right? The games usually have a, like a game loop that keeps on running at the, background, which enables you to, do things, do physics, and, like all these, calculations need to be done always. It just keeps on looping, and so there are all these different types of loops that are used in our programs, and that basically enables us to iterate. It just keeps on, it enables us to, keep repeating the same calculations, or, do repetitive work basically. So today let's look at 4 different ways in which you can, create these looping statements in C++. All right, let's get started. So let's first create a for loop. Okay, so that's first type of looping statement that we're going to look at is a for loop. Okay, so the way you create a for loop is, for, and then inside this, brackets, you need to create a variable. Okay, create a variable. Usually we create a, like a integer, a data type. You can even create a char, up to you, whichever data type you want. You just need a variable over here. So you just create a variable int I equal to 0. You can call this whatever you want. Usually I or j or is being used. So you can give it whatever name you want. We'll just say int I equal to 0. Okay, so we're creating and initializing a variable, and then the second part of, this line would be, so you're basically like, putting a semicolon. It's as if you are basically creating a variable, and then the second part you're writing, right? So that's what it is, right? So it's just that you're doing that inside of this for loop, right? For statement. So you're saying for int I is equal to 0. So this is the first part, okay, and the second part is I less than 10. That means, so this is a condition. So you created a variable, okay, and you will even initialize it with a value, and then here you have defined a condition, okay, saying that until I is less than 10. Then the third part is you need to now instruct the for loop what it should do. So we just say until I is less than 10, just keep incrementing I by 1. Okay, so this is what it is. So it's a trifecta, right? So you have these three components, 3 parts to this, right? So first is you're creating a variable called I and initializing it to 0, right? And then you are creating a statement, creating a condition. Basically, you're giving a condition saying that, until I is less than 10. So initially I's value was 0, and then you're saying until I's value is less than 10, just keep incrementing I by 1. Okay, so this is the 3 parts of this particular line, the for statement. And then we need to start and create the block, okay, using these flubber brackets, and inside the block, now we can actually put whatever we want here. Okay, so basically we'll just say we'll just do a small addition. Like we'll just say int x is equal to 10, and we'll say we want x to be added with I. Okay, so we'll just say int answer equal to x plus I. So what's going to happen is the first time it comes into the loop, x values is constant. Okay, it's just 10. All right. So and it could be anything else as well. Just to make a point, I'm just creating a variable here and putting it value 10. So now this variable is in this scope, in the main scope. All right. So we're just created a variable called x with the value 10, and what's going to happen is the first time when this loop gets executed, the value of I will be 0, right? So x plus 0, the answer would be 10, right? So let's just print that out. We'll just say stdc out, and we'll just print out the answer, and let's also have a new line character. All right, so that's it. So this is a for loop, right? So in the for loop, we're doing this calculation, basically, this is a formula, if you will, to compute the answer, you just need to add this number, that the number I that comes in each iteration, and we know that in each iteration the number I, we are incrementing it by 1, and that value, right? So in the first time, 10 plus 0 will be 10, so that we are printing, and the second time when it loops, so what's going to happen is I's value will be incremented by 1, right? So the second time when it loops, second time when it executes this for statement, when it comes into the for block, the i's value is going to be 1. So that means x is still 10 because it's a constant, and x 10 plus 1. Now the value is going to be 11, right? So we're going to, so this line is going to print 11, right? And again it will go back, and it'll again come and check if I is still less than 10, right? I is still less than 10 because the second time around the i's value would have just been 1, because from 0 it incremented to 1. So 1 is still less than 10, so it again comes into the loop. It just and here, since when it comes, it also increments the value of I by 1. So now it became 2. So 10 plus 2 is 10. 10 plus 2 is 12. So that gets printed, and so on. So that's how like it just keeps on adding 1 to I in every iteration. Okay, so let's just execute this and see the result that we get. So I'll just build and run this, and you can see that 10 is printed first, right? Because so we can see here, right? So 10 is printed first because that's a constant, and when it first came into the loop, i's value was 0, so it just prints 10, and it went out of, and it went again, right? Because so this keeps on iterating, it keeps on looping until i's value is less than 10, and i's value is less than 10. So it went again and it incremented. Now I became 1, so 10 plus 1 is 11, and then it printed it, and again it went and checked, i's value is still less than 10, so it incremented it. Now it became 2, 2 plus 10 is 12, and then again it went and checked, it's still less than 10. It just keeps on incrementing. So here after that it became 3, so 3 plus 10 is 13. It became 4, 5, 6, 7, 8, so 19, right? So it became, so basically the loop ran till the number, the number that is stored in the variable I is 9. And and finally, right, when basically, so finally the value was 9 over here, right? So x plus 9 is 19, right? So that's why 19 is printed here. And then it went again, okay, and checked if see, this is a very interesting, a very important point to keep in mind. What happened is, it's only printing till 9, right? It didn't, so we said I should be less than 10, and 9 is less than 10. Okay, so that's the reason 9 got printed. But then when it came back again, what happened was I got incremented. So so it increments I, and then it checks, like if it is if it first does this, basically it just first does this incrementation. Okay, it just first increments the value of I, and then it just checks if that value is less than 10 or not. So it incremented 9 to 10, so it became 10, and it checked if the 10 is less than 10. Obviously it is not, 10 is not less than 10, it is equal to 10, right? So it doesn't go into the loop, so it comes out of the loop, right? So that's what happened here, and that's the reason that the value 10 is not printed. Only value from 0 to 9 is printed. As a matter of fact, let's just remove this this silly addition that we are doing here. We'll just like print the numbers and see what is actually getting printed, and you can use it however you want. So this is a code block, right? You can actually even call another function, perform some logic here, add some if-else conditions, switch data structures, whatever you want. You can actually do it inside of this data block, inside of this code block. So we just like since we made the point, we just remove that this variable, and so we just print I, okay, just to see what are the values that are actually getting printed when you loop from 0 to 10. Okay, so initially the value was 0, and we're looping until the value is less than until it's less than 10. So let's just run this once again. So yeah, see, as we saw, now it's even more clear, right? So first the value was 0, and then 1, it just keeps on incrementing, right? Getting incremented 3, 4, 5, 6, 7, 8, and till 9. So that's how you can see that the looping is happening. All right, so cool. So this is one type of a looping statement that we can use. This is called for loop. Now the same looping can be done in another 3 different ways in C++. Okay, so let's go through them also right now. So this is one type of a for loop, so one type of a loop. So just comment this out for now, and the next loop we're going to see is the while loop. Okay, so here again, you say while, and then you need to specify some kind of a condition here. Okay, so we need to have a condition, just like how we have a condition over here. You just copy this, as a matter of fact, and paste it over here. Okay, so this condition comes here. So while is I is less than 10, what and we just start the code block. Okay, we not initialize I. Now the thing is, since we have not, so here we had created a variable called I, and over here there's no variable called I, so this is actually going to throw an error. So we need to actually create that variable. So in this instance, let's just create a variable called j. J is equal to 0. So we'll just create a variable called uh, j and initialize it to 0, and we'll use j here as well, so that so that we can all run it together at the end. Okay. So yeah, so this is and let's just also say that this is a while loop. Cool. So here while so we created a variable called j and initialize its value to be 0, and then we say while j is less than 10, we can just print stdc out j. Okay, so that's it. So this will also loop till j is less than 10. But the thing is here, right, we need to be careful because we are not we have created a variable called j, and initial is 0, and we have created a condition called saying that j until j is less than 10 keep printing j. But now this is an infinite loop, because there is no way this loop statement is going to come out. This is like when you want to create, as we talked about earlier, if you want to create some kind of a game loop or like an infinite loop, this is an ideal candidate. This is like an infinite loop because there's no way, at least as of now, j is going to be going to be bigger than 10. It's always going to be less than 10 because we have set the value to be 0, right? So if we run this now, it's going to actually run an infinite loop. I'll just show it to you. So if we just run this, I'll just show you this infinite loop that's going to run here. Okay, it's just going to keep on printing 0 0 0 over and over. See, it's just printing again and again. See, it's just printing again and again and again. See, so this is an infinite loop. Okay, it's just we need to be careful about those. If we need to we need to do them, if that's what we want, we should create program the infinite loops. But we should be aware that like unexpectedly having infinite loops will just stall your program. It's just like because here it's just the program will stop. It just keep on looping and it won't go to the next line. So yeah, just be aware of that. Now, so how do we like make this not be an infinite loop? So all you need to do is this thing, right? So here you have a command in the for loop. You had the command where you incremented the value of the variable by 1, right? So you need to have that here. So over here at the end of the while statement, or where you can put it wherever you want. Basically, you can put it at the beginning as well. So so we'll just put it at the end. We'll just say I plus plus. So that means so here it's j, right? So j plus plus. So that means the value of j is going to be incremented by 1 every time it comes into the block. It executes these lines, and at the finally in line number 17, the value of j is going to be get incremented by 1. Right, and so since the value is now 1, it checks again, is 1 less than 10? Yes, does this, and it keeps on doing it 2 3 4 5 6 7 8 9, and 9 is less than 10. Yes, it prints it out, and again it gets incremented. Now the value of j becomes 10. Is 10 less than 10? No, 10 is equal to 10, so it won't go into the loop. It'll just come out and exit the program. So we'll just see this also in action. Now we'll just build this and run this. Yeah, as you can see, like while loop 0 to 9 is getting printed, right? And it's not a infinite loop now because we have this incrementing statement. So that's cool. And we'll also see the next kind of statement that we can use for doing this loop. Okay, so just like while loop, there's also something called the do while loop. So what does that mean? So this while loop, I'll just show you one one nuance of this while loop. So basically, this while loop will run, this basically this line number 15, right? It'll come only into this block only if this condition is satisfied. It'll otherwise it won't even come into this block. So that means if the j value of j was 10 already, or like 11, anything which is not less than 10, anything which is not less than 10, right? So that means it will be here like similar to a if block, right? Over here it comes and it checks, is j less than 10? No, because j is now 11, so it won't even come and say. It'll just directly go to line 18 and then exit the program. We'll even build this and see. Okay, so here if you see, nothing's going to get printed over here. See, so nothing got printed while loop, but nothing got printed because the condition didn't even get satisfied. Like this line, j is not less than 10, so it didn't even come inside the loop. Now there are instances where you at least want to even if the condition is not satisfied, you want the loop to execute the lines inside of the code block at least once. So that's where the do while loop comes in handy, right? So it's basically the do while is like a variation of the while loop, if you will. So here what you will do is like say do. Okay, so do. Okay, don't check for anything, just don't check for anything, just do it. Okay, so do this. Okay, bunch of statements, like you have here. Okay, so a bunch of commands while, right, the condition. So you have the condition here. So like basically let's have the same condition, right? So we'll just put In this case, we say k is less than 10. Okay, so and we'll also create a variable called k is equal to 0. So, or let's put 11. Okay, so now here I've just created the same scenario here. Okay, like instead of j we're using k, but ultimately the value is the same, right? So k, the value, we're setting the value of k to be 11, and we check the condition while k is less than 10, right? And we'll just have the same kind of we'll just print the value of k. Okay, so we'll just say print, so instead of j it should be k, and here again k. So what's going to happen is, so since the since the condition is at line number 25, right? So it will, no matter what is the value of k, it'll just print it once, at least one time will print it, and it'll even increment the value of k, right? So when it comes here, the value of k would be 11, as a matter of fact. If we print it, or print the value of k at line 26, right? So it's going to be 12 because it got incremented over here, right? So that's no matter what, as a matter of fact, let's just see that, right? So if you just print out the value of k outside, so we'll just say outside k value, so we'll just print it out, k std and del. All right, so we'll just print it out, and let's see. So in this case, what's going to happen, the value of k is 11 over here, so it's going to print 11, and the value of k is going to get incremented. So from 11 it should become 12, and over here, it got printed already. So the segment got printed, right? And then after that only we're checking, is k less than 10. It is not, so it won't continue the loop. It'll just come to this line 27. So at this line 27, the outside k value, right? So that would have become 12, okay, in this main block, in this main scope. So let's just run this now, and as expected, see, the value was 11, and when we printed it out, it was 11, and then in line 23 we incremented the value of k, so it became 12, right? So that's what gets printed when we printed outside once again. So as expected, right? So that's really cool. So and yeah, like if k's value was 0, and it will loop, right? So basically, like, let me just remove this, and so yeah, so now k value is 0, so it'll first say print 0, and then like check if it's still 0, if the value of k is still less than 10, and it will just keep on looping. Now the answer, the value that we are going to get is going to be very similar to the value that you want to get over here. If we just run this now, we can see that it's going to give you the same results as what the while loop gave, because the values are similar, right? So here again you can see do while loop is like from printing from 0 to 9, because initially it was 0, then the value got incremented, it did the check, and then again since it is less than 10, it just kept on doing it until the value was less than 10. So that's the looping that's happening over here in the do while as well. So see, we can, so this is really cool, right? The same kind of a looping, you can, we have already seen 3 different ways in which you can do it. You can either do it with a for loop, or you can do it with a while loop, or you can do it with a do while loop, right? There's another way as well, that is really cool, and it's like very useful actually, like especially when you're using data structures such as a list. So let's look at that as well. So the other way, like the fourth way in which you can create a looping statement is something relatively newer. It's a relatively new syntax, which is basically for each loop. Okay, so for each also, like you won't say for each here in other languages, like you actually literally say for each, but here it's just you just say for, and then like create your variable int I. Okay, and this is basically what we're going to use as an iterator. But in order to use a for each loop, you actually need like an iterable data structure. Okay, anything that could be iterated on, right? So an iterable data structure would be, a common iterable data structure would be a list, right? So let's just create a list, or like let's just create an array. Okay, so a simple, just create a simple C++ array. So we'll just say we'll create an array of integers. Okay, so we'll just say int numbers, let's just have 10 numbers equal to, and we just initialize the numbers 1 2 3 4 5 6 7 8 9 and 10, right? Yeah, and like let's iterate over them. So for int I, so ijk, we'll just call this L. Okay, so just to we can have different variable names. So int I, okay, this is another, we're creating a variable here, int L, and the value of this L is going to be the value is going to be each of the values of this list, one after the other, until the end of this array. Okay, so until the end of this array. So it doesn't necessarily need to be an array. In this case, we are using an array, but it can be any iterable data structure. All right. So here we'll just like say numbers. Okay, and yeah, we need to put semicolon here, right? And then yeah, so now let's just print it out, stdc out l and std end l, right? So yeah, so that's it. We can see that, like now here we didn't have to do that condition. We didn't, I mean, yeah, there's no condition or there's no incrementation that is going on here, as we had in the other ways. Like in do while you had like a condition and like this incrementation that is happening. In while statement also you had this condition and this incrementation, and even in this for loop you had like this condition and incrementing that is going on, right? Whereas for a for each loop, you don't actually need that. You can just say, like int l, and then the numbers. You have the numbers, right? So numbers 1 to till 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So all the numbers that are there in the list. So here we can just print them out one after the other. So like so here we are just we'll be able to print out all these values one after the other. So basically, the first time when it comes into the loop, it just takes the first value in the array and assigns it to l, and when it prints it out, it will be l. The l value of l will be 1. And the next time, it'll get the second value in that array and assign it to L, and that's what we're going to print. So like that, we'll be able to print till the end. And because we're doing that, literally all the elements of this list is going to get printed, including 10, right? Because there's no condition saying it should be less than 10. It's, all inclusive, like basically anything, any value in your list, even if you add more values, they are all going to get used in this loop. So until the end of this array is just going to keep on printing the values. Okay, that are there. It's just going to keep on looping. It's going to loop. So the number of times this for each loop is going to happen is based on the length of your iterable data structure. Okay. In this case, it's going to be looping for 10 times. So let's just run this now, and we can see that as expected. Yes, so this is also just looping, 1, 2, 3, and it's not incrementing per se, right? This is just, it could even be random numbers. We just put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 yeah, for convenience sake, but it could just be any numbers, anything. Okay, but whatever value is there in the list is just going to get picked up and printed one after the other until the end of the array. So yeah, so that's really cool actually. Like for each loop is really useful, especially when we want to iterate through all the elements of a particular data structure, particular iterable data structure, right? So let's just let's put a name for this as well, and let's run all the loops together and see it in one go. All right, so the first loop that we have is the for loop, for loop, for loop. Okay, and then we have the while loop, and then we have the do while loop, and then we have the for each loop. So 4 different types of loops. So let's just run all of them together, one go. See, these are the different types of loops. Like for loop, while loop. For loop syntax is this, for given a variable, condition and incrementation, everything, you just put everything in a single line in the for loop. So in a way, it's a bit more cleaner. You just get to see what's the variable that you're using, what is the conditional which you are going to be using that, and what is the incrementation that you're going to be, how are you going to increment that variable. Everything is in the same line. It's a bit more succinct, but yeah, like while and do while have their place, especially when you want to create like infinite loops. And yeah, for each is what you would use when you want to iterate over an iterable data structure. Okay, so each of these loops have their place, so that's what we need to keep in mind. All right, let's just run this now and see what's going to happen. So yeah, and we know what's going to happen, right? So it's because we saw everything, one by one. So yeah, like, so for loop, this is for loop, it's looping through, all the 10 items, looping till 10 values. And, we have the while loop. While loop is not executing because I think, we have the value, it doesn't even come into the condition because, it doesn't, it come into the loop because the value of j is 11. So let's just put that back to 0 so that, while loop is also part of this, execution. So we'll just like run it once again, and yes, you can see that we have for loop, right? And then we have the while loop, do while loop, right? And our for each loop. So all are getting executed. So yeah, all these different ways in which you can do loops, and each different the for loop, while loop, do while loop, and for each loop, each have their place. You can use it based on like how you want. I mean, these are just tools that are available for you to do this iteration, right? To enable you to make the mission do the iterative work, to do the mundane repetitive work, and yeah, use it based on how you need it. Basically based on your requirement, use each of these loops, because each of them have their own nuances, and the way they are used, they have their place. Yeah. So yes, I hope this video on loops in C++ was useful. Thank you so much for watching, and I will see you again in another video. Cheers.